But before we can get into the why, though, we have to talk about programming in general and what makes programs good. The only reason I've ever heard of people using TypeScript is because they think it makes their programs better in some way. Usually catching, type-related bugs earlier, but sometimes for other reasons. The bottom line is TypeScript seems to exist because people think it makes their programs better, or at least, makes them a better programmer or something. So first, I think we have to analyze what makes programs good and what makes us as programmers good programmers. A quick summary of just programming languages in general is that they literally exist to allow us as programmers to create abstractions. Like, we could write our programs directly in machine language, right? Or at least in general purpose, machine language that gets translated to different architectures if we're writing in a higher level language purely, for the sake of cross compilation or something, right? But we don't do that, right? Especially as web developers, we are far removed from writing machine code directly. There are many layers of abstractions between us and the hardware. Abstractions. Exactly. Abstractions are what makes programming, at least in my opinion. And programming languages, have a reason. It's like what gives programming languages a reason to exist at all. Abstractions are what allow us to write programs much more quickly and effectively than we could otherwise. So to me, it all comes down to abstractions. Programming is abstractions. Like I'm sure if you've ever programmed with me, it's something you're going to hear for certain quite often, whether it's in code reviews or discussing the design of something or whatever it happens to be. Programming is abstractions, and that's what I care about, and I think for good reason, which we'll get into. But not all abstractions are created equal, right? So I once worked on a web application, it was about 10 years ago now, that was written in JavaScript on the front end and Java on the back end. And I think, JavaScript at the time, I'm sure we used jQuery. And I think at one point we even upgraded to like Backbone or something, really, groundbreaking, I know. The back end code, though, was incredibly verbose. It was so verbose, in fact, that I just got sick of writing it. It felt like my day was basically filled with creating or like trying to get my editor to create or refactor endless getters and setters and interface classes. Java has certainly gotten, I think less verbose since then. But at the time, we were using, pretty much like, quote, cutting edge Java. It was so bad, in fact, that I basically stopped writing Java code. And it's not because I just worked on the front end, although I did do a lot of that because I didn't want to work on the back end. But I actually wrote my own Lisp to Java code generator. So my Lisp code was a tiny fraction of the Java code that it output, but the output did exactly the same thing. So my Lisp program was tiny, did the same thing as tons of lines of Java code would do, but I didn't have to write near as much. It was fantastic. I was so happy. It made working that job so much better. Obviously, this isn't groundbreaking. Many programming languages that exist, they exist to compile down to other languages. And many times, they exist purely to sort of create and allow us to use higher levels of abstraction. Somebody's like, oh yeah, C is great because it runs on a bunch of stuff, but I want to also be able to use anonymous functions, and I don't want to wait for C 29, 2029 or whatever it happens to be, And so they write something that compiles down to C, but allows you to write in higher level abstractions. It's great. Definitely the route a lot of programming languages have gone. So yeah, it's not groundbreaking. Is all I'm really saying is like I did something that was cool. I thought it was awesome, but it wasn't groundbreaking. But it gets back to my sort of main point, and that is that programming languages are all about abstractions. But you also need the right abstractions. And your programming language, and this is critical, it needs to enable you to use the best and most effective abstractions. The Java code that we wrote was a horrible mess. It was incredibly difficult to work with, and it was riddled with endless bugs. I've worked on many Java projects, and I am convinced they all end up this way. Now, I don't actually necessarily directly blame Java, although you could argue it's probably what I should do. But I think the real problem is that Java just makes it difficult to create some abstractions that would make your code better, that would make it so you don't have to write as much code to accomplish just as much, that would not leak things, that type of stuff. But in the Java world, at least when I worked in it, I haven't worked in it as much recently, but when I did, the community even sort of discouraged creating new abstractions. So when I worked at this company, I originally attempted to create some better abstractions directly in Java using what they call the Reflections API. So it's like something the Java language, provides essentially. And it was cool. The end result was you could write much less code to accomplish the same thing, right? Abstractions, great, awesome, But it was wildly unpopular where I worked. And in general, basically the attitude was that if you reached for reflections, then you were doing something wrong. That's not what you should be doing. You got to use Java the way Java's meant to be used, the way it was, designed, blah, 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 right? Well, this is actually an attitude I still see in React and, web application, like the TypeScript community as well. It's not near as extreme, I think. There's definitely a lot more openness, around this, but I think it's this very similar attitude. The attitude is that programming languages should actually place restrictions on us as programmers so we don't make obvious mistakes. This is sort of Java 101 in my opinion. The theory that good programs are programs that any programmer can just jump into and start writing code in and not have to worry about introducing a type error or whatever. But if good programs are really about good abstractions, what does that have to do with programmers, being able to quickly jump in and start writing code? It doesn't have anything to do with that. In fact, it's the opposite. And this actually is, I think, tied into a much larger point. A lot of people will be like, well, why do we use Java then? Why do we use some of these other languages? Without going too far off on a tangent, I think a lot of it is actually based more on sort of capitalism and our ties into that. So a lot of the programming that we do is via or for companies, right? And companies do want programmers that are interchangeable. They want us to be cogs in a machine, right? Like they want to like a programming manager, a company, their biggest dream, right, would be if they could just grab any programmer off the street, plug them in, and they just start cranking out code. And, that's their biggest dream, right? And so I think really things like Java are kind of their attempt at that. Like, oh, we're not going to let you do most things, but the advantage of that is it should be easier for us to pluck a programmer off the street and just have them start writing Java code. Like if you compare that to some of the Lisp projects that I've worked on, it's the complete opposite. Like it might take you months to learn the Lisp project well enough to write any useful code. Whereas yeah, it's kind of true. In a Java project, you can pluck someone off the street and they can start writing code. But the big difference is the quality of those projects is light years apart. The Java projects, 100 million lines of code and just full of bugs, and every line you write leads to more bugs. The Lisp one, yeah, it took you longer. You can't just use any old programmer. You got to have a programmer that actually knows what they're doing, maybe. But the end result is you're going to pay a lot less for it, and the quality is going to be a lot higher. You're not going to have to rewrite it every 5 years.